Hello everyone, welcome to MATLAB Simulink Essentials. In this video, we will see the simulation for single-phase full-wave controlled rectifier with RL load and freewheeling diode. We will use different components present in the library browser and we will try to understand the concept of firing angle. In the previous video, we have seen the simulation for resistive type of load. Now let us change this branch type to RL. We will consider this inductance as 50 millihenry. Now if we want the firing angle to be 60 degrees, then our phase delay will come out to be 3.33 milliseconds. So let us apply this much delay. So for S1 and S2, this phase delay will be same, that is 3.33 milliseconds. But for this switch S3 and S4, we can add 180 degree plus 60 and we can find out the firing angle delay, or we can simply add this 3.33 milliseconds to this 10 milliseconds, so it will come out to be 13.33 milliseconds for the switch S3 and S4. So now save the changes and run the simulation. Open this scope block. So this is the output voltage waveform and here is the current flowing through the load. So in the positive half cycle of the AC supply, after this firing angle of 60 degree, this thyristor first pair S1 and S2 will start conducting, and here you can observe the output voltage waveform across the load side. So during this period, inductor will store the energy, and after the end of this positive half cycle, this thyristor will try to get reverse bias, but inductor will release its energy and keep this thyristor pair conducting for some time. So this same thing will get repeated for this second pair of thyristor after the delay of 180 plus 60 degrees. So here you can observe the current waveform. So at time of 10 milliseconds or at theta equals to 180 degree, our voltage is 0, but here you can observe the current has still non-zero value. So as we are using a RL type of load, this current waveform is not in phase with this output voltage waveform. As we are getting some part of output voltage in this negative portion as well, our average output voltage gets reduced. So to remove this voltage in this negative portion, we use the freewheeling diode. So let us take a diode present in the specialized power system library. Connect this diode in parallel with this load. Now save the changes and run the simulation. Open this scope block. So here you can observe the change in the output voltage and current waveform. So now as we have used freewheeling diode, we are not getting any portion of output voltage in this negative portion, because now inductor will release its energy through this freewheeling diode. So eventually our output voltage will get improved, or its value will get increased. And here in this current voltage waveform, you can see the improvement in this waveform as compared to the previous one. So that's all from this video. Check out the description box for the quiz and do answer them in the comment section. Like, share and subscribe to the channel Start Scratch, and do check out our other videos to learn similar skills through our bite-sized content.